Integrated activity planning is a complex exercise in most upstream oil and gas assets. This demo shows how we are applying our unique game AI approach to support asset teams in making difficult decisions. This first example is a logistics problem. We were asked to support an investment decision and additional helicopter capacity for daily transport of people to offshore operations. This particular asset has an existing but aging fleet of helicopters and was facing an increasing longer-term demand for transportation. On a day-to-day basis, the logistics team was already struggling to meet daily variations in people, number of offshore locations, and frequent break-ins to the plan. Buying additional aircraft capacity seemed a no-brainer, but how to justify? And what would be an optimum fleet composition? Would it be better to have a few large aircrafts or more smaller ones? To make matters worse, the company's management was not convinced that the existing capacity was fully utilized and challenged the team on the need for additional capacity. We were asked to help with a data-driven approach. As a demo, we used our game approach to develop an AI assistant that learns how to optimally allocate people to available helicopters based on offshore demand. This is far from straightforward, as there are easily hundreds of thousands of different combinations to evaluate and choose from for every single day. The game includes key elements and rules such as the fleet capacity, demand forecast, aircraft downtime, maintenance routines, and various constraints such as the maximum number of offshore locations per trip. The objective of the game is to optimize the daily capacity, in other words, the helicopters, while taking into account the relevant constraints. The game is played by an AI assistant, which learns itself to find the optima on a daily basis. We then play this daily game over and over for a long-term demand forecast, analyze the results, and test alternatives or different strategies. One of the differentiating elements in our approach is that we always start with a simplified and low-cost demo to give our clients sufficient confidence before scaling up. In this case, we used a comparison of 2 large aircrafts versus 3 smaller ones. The objectives of the demo were to show that we can use our game AI approach to consistently compare different scenarios, to give us insight before adding more complexity, and to demonstrate to the client's management that optimally planning is possible. As an example, take a single day from the 3-year demand forecast. Our AI assistant has learned itself how to optimally allocate the demand to the available capacity. We can then use this to consistently compare 2 large aircrafts versus 3 smaller ones. Scenarios or strategies can be compared by using a wide range of data-driven metrics. For example, we can use the percentage of days that demand has been met. We can also look at the number of days during which there would be an unused helicopter, therefore giving an opportunity to perform maintenance or being more robust against unforeseen downtime. Once we are confident about the AI assistant in the simplified game, we can add more complexity such as unforeseen downtime, scheduled maintenance, uncertainty in demand, or different capacities. This phased approach gives transparency and understanding and limits the upfront financial exposure for our clients. Another project that we recently started looks into the maintenance strategy for a brownfield operator. Similar to the previous logistics example, we are asked to support the client in making some strategic choices, such as investing in additional execution capacity, changing the skill set of the maintenance crew, choosing between long campaigns per location versus short trips to address the highest priority scope, and finding the right balance between safety, production safeguarding, or optimization and cost. The number of permutations in this problem is enormous, with tens of offshore locations, thousands of work activities, and 2 workboats, each having a certain set of skills in the crew. Our game AI approach suits this kind of complex problems and gives a lot more insight for quality decision-making. Integrated activity planning in oil and gas is an area where AI can add a lot of value. Day-to-day planning often deals with huge amounts of options, different value drivers, and various constraints and uncertainties. Manual planning workflows are doomed to be suboptimal in such situations. Our game AI approach suits these problems extremely well. The AI assistant can provide the necessary support in making strategic decisions or assist human planners on a day-to-day operational level. White space energy. Navigating complex decisions in oil and gas through game AI.